Greetings, everyone, and welcome to the latest installment of the Senturus Knowledge Series. Today, we're proud to present the topic of Snowflake's cloud data platform and modern analytics. Our agenda today, after we do a few brief introductions, we will discuss Snowflake. We're joined by our partner Snowflake here, and they're going to cover the cloud platform and all of its various benefits and uses. After that, we'll do a quick Senturus overview, discuss some additional, mostly if not entirely free resources, and then we'll get to our question and answer. So make sure you stick around after the presentation. So introductions, I'm pleased to be joined today by Chris Richardson, who is a sales engineer at Snowflake. He's been there since mid-2018 as a senior sales engineer. He's a seasoned business leader with almost 2 decades of experience in data analytics with roles spanning from business intelligence to marketing and strategy. He's skilled at developing deep insights, innovative approaches, and strategic solutions across many industries and technologies. Prior to Snowflake, Chris was a solution architect at Teradata, and prior to that, he held roles in consulting, business ops, marketing, and Lean Six Sigma, where he learned his hands-on skills in BI and data warehousing to create a culture of data-driven decision-making. My name is Mike Weinhauer. I'm the Director of Training and Content here at Senturus, and have been designing, delivering, and selling business analytics solutions for a long time, over 20 years at this point. So with that, I'm going to hand the floor and the microphone over to Mr. Richardson, and the floor is yours. Take it away.
Okay. Thanks, Mike, and thanks everyone for coming to the webinar today. As Mike said, I work at Snowflake. I've been there for a couple years, and we're going to talk today a little bit about Snowflake, who we are, some of the main problems we solve, and then get into a demo. And I really am not intending this to be a sales pitch. You're going to have the slides. You can read those slides later. I'm not going to read them to you, but I will kind of run through them quickly here before the demo, and just so level set and everyone's on the same page before we jump into a hands-on demo. So as Mike said, I've been in the data space really for 20 plus years, and it's interesting over the last 5 or so years to see all of the media attention around data, and data being like oil or your most valuable resource. And you know, that's interesting, and I think a lot of us are data folks, but we realize that it's not just the data, it's how you use the data. And it's something that a lot of people have struggled with over time, is like, how do I leverage this data that I have to turn it into an asset that can be a competitive advantage? And I really think that Snowflake has taken some strides in this area, and I'm happy to kind of share this with you today and kind of explain our journey, and then show you the product. So sort of, first of all, why, you know, what's changed, right? We've had data for a long time. We've had it centralized, and really it's kind of these 3 sort of levers or kind of things that have happened in the industry. One is this maturity and growth of cloud computing. So the idea that you can have an on-demand resource that virtually has unlimited storage and unlimited compute is different, right? And if you could have a database on top of that, that would actually be something that could allow you to leverage data in a different way, and that's really what Snowflake's done. The second thing is, in order to make this data actionable, there's a lot more data, and that data has insights that the data that we had before didn't provide. So there's just a ton of data. IoT is such an exciting space, especially just even in the last couple years of how much that's gone mainstream. Tons of data coming off of websites and social media that can be combined with the data that you have already to get new insights. And then lastly, there's a lot of really new patterns around analytics, new libraries, tons of new tools, and really the desire, the kind of thirst for analytics is really taken off really in the last few years. And part of it's driven by the media, part of it's driven by these things, more data and new technologies that make it happen. So when the founders of Snowflake, you know, sat down and thought about this, and the product is a pretty, you know, it's a pretty new product, right? We've been around for only 5 years. That GA about 5 years ago. They they were trying to tackle some of these big problems and turn that data into assets. And they looked at the market, and the first one was they wanted to help people make better and quicker business decisions. And what this meant was all of your data needs to be in one place. You can't be hopping around to different databases to run your analytics, and you need to sort of have a centralized storage layer for all of your data. The second one was it can't be difficult for you to scale this infrastructure. If people want to use it, you should have the resources available to use it. You shouldn't have to do an upgrade, remove hardware from your data center, replace it with new hardware, install patches, things like that. So they wanted to make this cost effective, and they wanted to make this easy for people to do. And then the last piece of it is, they wanted it to be easy for people to consume, this asset. And, I like to kind of reflecting on how I was going to say this is I worked on projects, and there's some people who are the haves. They have access to the data. They can run the queries. They can get whatever data they want loaded in a timely manner. And then there's some people who have to wait. They get throttled. They can't run their jobs. They're not trusted to create certain objects in the database. And so there's the haves and the have-nots. And what we've done really with Snowflake is try to eliminate those barriers, and now everyone can really get access to the data and start doing the analytics that they want to do. So, we've created really what we think is the next generation of a data platform. We call it a cloud data platform, but this idea, it's been around for a long time. And even in the late 90s, the first data warehouse I worked on, it was a Teradata system on-prem, and it was an EDW. It was all of the entities in the business, all of the things about manufacturing, all of the things about testing the devices. It was all in one database. And the size of that was 800 gigabytes. And I really wanted it to be a terabyte. That was the big thing back then, but it was 800 gigabytes, and that had all the data, and it worked fine. We could model all the data. But where it started to break down was with users. So when we started to pile on more users onto that system, queries became slow. The amount of resources were fixed. We had to start to throttle people. They couldn't get the access to the data that they needed. So along came kind of like around the same time the cloud was born. People started to build services in that, and one of those was databases. So products like Redshift, which is a great product. It was the very first product really in the cloud that had a MPP type architecture to do data warehousing, and it gave you what you wanted. It could write SQL, which people were used to. It ran fast queries, but just like the on-prem systems, it started to break down when a lot of users use the system. And then along the same time, these new data sources coming in, different kinds of data, whether it may be structured data or semi-structured data, a lot more data. So the volumes were starting to get kind of push the limits of these systems, that there was a new generation of that had a lot of promise, the Hadoop kind of environment where people were creating data lakes. These data lakes were great because they could store all kinds of data. They had separated sort of this idea of storage from the processing of that data. So you could have more users, different clusters running at different kind of on that same workload of data. The problem with this was twofold. One was it wasn't a SQL database, right? People were used to SQL. They wanted to use transactions. They wanted to do updates and inserts and things that they used to do in their data warehouse, but they couldn't do that in their Hadoop environment. And there were some strides made to do SQL on top of Hadoop, but in the end, and we're still seeing this, it's really hard to get consistent results. The BI kind of queries, the interactive workloads that you need for a business, it's hard to get that out of Hadoop without a lot of special tuning and a lot of resources, really specialized resources to make that happen. So like I said, there's a lot, this isn't new. People have been trying to centralize data and kind of democratize it for a long time, but we really think with the cloud, with the ability to handle different kinds of data, we've got that in Snowflake. And I'm gonna talk to you why we think about that in just a second. So This isn't really intended to be a architecture that you might have, but it's sort of meant to represent the landscape that we see today across different customers. It's basically it's very complex. Today, there's a lot of different data is landing in different places, a lot of different tools. It's coming from a lot of sources. So it might, it might come from Kafka and streaming. It might be a change data capture off of your ERP system. You may be pulling it from other systems like Salesforce.com. And then usually there's some sort of transformation that happens on that data. Could be done through SQL and Hive, could be done through Spark, but then it finds its way into a data warehouse. Sometimes there's data marts that are peeled off of that data warehouse because they have capacity limits on the data warehouse. You've got to back it up in other systems. There's dev systems, prod systems. And then usually it has to end up going out into some other structure. It could be you're sending files out. It could be people are sucking it into a notebook. It could be a Tableau data extract. There's a lot of ways that people are pulling data out. And kind of the net here is it's complicated. All of these systems cost money to maintain. Each of these connection points is a potential point of failure, and throughput could be an issue. And lastly is that you're really losing governance across this whole ecosystem. It's hard to keep track of where the data is, who has it, is it secure? So that's kind of the big problem that Snowflake solves, is that it allows you to eliminate a lot of this complexity. You can put your data in one place, and you can do these different workloads on top of it. And the platform itself can run in the cloud, so it runs on each of these different cloud vendors. So kind of moving on. So what like why, that sounds great. I believe you, Chris. You seem like a nice guy. What makes it different? And the biggest thing that I want to share with you is it's this architecture. There's a new architecture. We call it shared data multi-cluster architecture, and that is what Snowflake's built off of, and that's what makes it different. I'm going to talk about the architecture here now. Is that there's really three parts to the architecture, and the first one is this idea that at the core there's a storage layer. And this is a single place to centralize as much or as little data as you want. So you get to pick what goes there. You can ingest structured data, you can ingest semi-structured data, and it leverages the elasticity and scale and cost effectiveness and durability really of blob storage. So in Amazon, this would be in S3 as an example. The second piece of the architecture is this multi-cluster compute. These blue gears that are on the outside, or in the middle, I mean, they are they're compute resources. They're clusters of computers. They're separated from the storage, and they operate independently. So they eliminate resource contention between different workloads, and those clusters themselves, more importantly, can scale up and scale out on demand. So if you need more resources to do a certain job, you can choose through policy-based settings to make those scale out, scale up, and you can get your jobs done quicker, and you pay for kind of those resources by the second. And then the last piece of it is really the brains of the operation. So Snowflake itself runs as a managed service, maybe a little bit like Salesforce is a managed service. We take care of provisioning all of the equipment. We keep the service running across 3 availability zones. We handle the transactional consistency. We ensure that performance is optimized, query plans, that kind of thing. We handle authentication, role-based access control. We capture metadata on everything that's going on in the system, including the data and queries and everything that's run. And we allow you to share this data securely out, kind of without moving it. And I'm going to go through that a little bit in the demo. And as I mentioned, all of this runs across 3 cloud platforms. So the Amazon is where we started about 5 years ago. Azure came online a couple years ago, and then Google just came online a couple of weeks ago. But the benefit of running on all these platforms is that we allow you to you can back up data across the different cloud platforms. You can replicate, so you can provide a DR environment if you wanted to run in Azure and then back up to AWS or fail over to AWS if Azure was some reason down, or if you just wanted to move from AWS to Google because you're getting better cloud pricing from them, you can do that. So our competitors, it's an interesting dynamic because our biggest competitors right now are Google, AWS, and Azure. They all have data warehouses that run in the cloud. But we also are their biggest customers. We spend a lot of money with these folks and we run on their platform. So it's an interesting dynamic. Okay, and then another way to sort of look at this before I jump into the demo, which is going to be the next slide, is we've got this cloud services part. It's the brains of the operation. It's a managed service. We've got a centralized data store that's in blob storage. And then we have these independent compute resources that use these t-shirt sizes that represent the size. These compute resources can be used for different workloads. It can be used for ELT. So these folks up here are just a partial list of the partners. They've written connectors to Snowflake using our ODBC or JDBC drivers. They orchestrate ETL or ELT into Snowflake, and they leverage these compute resources, which we call virtual warehouses. We also have some services for data engineering where we can ingest data without using an ETL tool. So if it's streaming data, as an example, we have a tool called Snowpipe. You land the data in blob storage, we automatically pick it up and load that raw data into Snowflake. Similarly, these same compute resources can be used for BI. So if the sales team has BI dashboards, they can have their own compute resource. If data is being loaded the same time the sales is querying it, they're not impacted. It's consistent because it's read committed, so data has to be committed before you can read it. So their sales is reading the data, running their queries, they're going to get consistent performance. Even if the load fails and it needs to get reloaded, that's not going to impact them because they're completely isolated compute resources. Same thing if there's a data science team, they have a Jupyter notebook, they're running Python, they can run independently, spin up these resources as their own. If they need more compute resources, they can scale them up automatically, scale them down when they're not needed. The other dimension of elasticity that we have is scaling out. So imagine the sales team at the end of the quarter, they have a lot of queries to run. We can automatically scale out horizontally. So if there's queries that are running and a new query comes in and it realizes that it doesn't have enough resources to execute that, so it can either queue the job and wait for resources to be available, or what it'll do if you decide through configuration, and I'll show you this in the UI, spin out horizontally. And then there's a couple other use cases which I'm going to go through. You can share data securely with external or internal folks, and we have a capability in our product called time travel. Time travel allows you to query data as it was in the past. So it could be 60 seconds ago, it could be 30 days ago. It's up to you. You can configure like how much time travel you want to have. You can have 0 if you want to, and then you can through some SQL extensions, you can query data at different points in time. And there's nothing you need to do on that. You don't need to do any special data modeling or anything. Comes with the product, and it's really nice. And then lastly, because of the way the architecture works, there's one copy of the data. Our databases themselves are just logical objects. So if you need to create a dev environment that's a copy of your prod environment, you don't need to buy additional hardware. You don't need to buy more capacity or expensive tools to move that data. You just need to do a 0 copy clone. And I'll go through this in the demo as well. Okay, so jumping in here, jump into a demo here. So Snowflake is a web service. This is an account I have. It's a demo account. You can see here it's called Demo 49. It's running in AWS East region. So I'm going to log in as a user called John. John is a DBA, and Jane has asked John. Jane is the analyst who's asked John to load some some data for her. And this data is, is some trips data. And actually, I realized that I wanted to go back to this one slide here. So let me just kind of set up the demo here quick. I forgot to do this, is that we're gonna load two kinds of data. We're gonna load some structured data, which comes from an open source city bike. It's a bike sharing system in New York City. Basically, you pick up a bike in one location, drop it off in another location. That's considered a trip, and then there's some data captured about that trip. And here's the data model that we're going to go through, is that this trips table is sort of the fact table, and there's a couple dimension tables, stations, and programs. And then we have another data source around weather. And weather is observations of weather, and that's semi-structured data. It's in JSON format, and it's related to the trips data based off of the location, New York City, and the time. So we're going to use that data source to compare how weather impacts trips, and that's really what Jane's interested in, is that correlation between those two things. So jumping back here to the demo. So this is what the Snowflake UI looks like. I'm logged in as John. I'm a role of DBA. Before I jump into running queries, let me go through some of these icons on the top. First one is databases. One thing about Snowflake is that if you're used to working in a relational database, you will find it very easy to work in Snowflake. It's an ANSI SQL database. The SQL we write, the way you interact with it is very familiar to someone who came from a traditional database background. So there's databases. You can have as many databases as you want in Snowflake. There isn't any sort of capacity limits in Snowflake. We are bounded by the amount of data that you can put into S3 or a region in Amazon, which is pretty much unlimited. So in a database itself, it has schemas. Those schemas have tables, and those tables have rows and columns. So you can have views and other database objects. It's very, very familiar. The second one, which I've talked a little bit about, is the compute resources, which we call virtual warehouses. These are clusters of compute. You can just, if you have the permission, the privileges, you can just create your own. Let's just say I wanted to create a warehouse called test. You can pick the size of this warehouse. So Snowflake, you pay for Snowflake by the second. So every second that you're using one of these warehouses, you're paying for Snowflake. The product itself is priced using a system called credits. You buy credits and then you consume those credits. And a credit is basically one node per hour. So this is a large warehouse. It's using 8 nodes. It'll cost you 8 credits per hour. The smallest one is 1 credit per hour, and that's a small. So this just has 1 node in the cluster. So you pick, when you're defining a warehouse, the size of the cluster. You choose how you want the cluster to scale horizontally. So again, this was that case of the sales team scaling out horizontally when they need it. But you can start with just 1, and then it will go all the way to 3 if you need it. You have some different policies that you can decide on how you scale, how aggressively you scale. And then if someone isn't using the warehouse, it can be shut down. We'll also shut it down for you automatically. This can be set down as low as 1 minute. And at the same time, if the warehouse is suspended, you can have it so when someone comes in on Monday morning, the warehouse will start up. So they don't have to do anything with, you don't have to worry about shutting this down. You don't have to worry about starting it up, and you only pay for this when you're using it. So it's not on all the time, and that's a really great cost saving. So I'm just gonna hit finish here. And generally what happens here, of course, I'm doing a demo now that took a little longer than it usually does. It generally starts up right away. And the reason it starts up right away is because we've pre-provisioned these resources for you on the Snowflake side. When you request 8 nodes in a cluster, we give you those 8 nodes, and you now have a warehouse. It's running. You have this resource, these 8 nodes available to run queries. And I'm just going to shut this off because I'm going to I'm going to show you in a second, like how, different ways that you can sort of provision these resources and use these resources. Okay, so moving on here to the Worksheets tab. I'm going to start out by loading the structured data, which is this trips data. You can see here I have a database called City Bike. If you remember, I had a couple tables in there. One of the things that maybe takes a little getting used to in Snowflake is this idea of setting the context. So because you have multiple databases, and those databases can have multiple schemas, and you also have the ability to have multiple roles. So roles are how you get access to certain objects, role-based access control. And there's also multiple warehouses. You need to tell us which ones you want. And you can do that either through SQL, you can do it through the UI here, or you can have default ones. But for this example, I'm just going to show you kind of right here. I'm going to set some context. And you can see here, I'm actually going to create a warehouse that isn't running right now, but I'm going to create a warehouse. It'll suspend in 5 minutes. It's a small size. And so now I've got this context set. I'm going to use this role that is going to drive what objects I see, this database, this schema, this warehouse. So now I can actually run some queries. And so you'll see here now this warehouse is green. It started up. When I ran that first query, it was configured to auto resume. And it started up so I can run queries. So I'm just running some queries on these little dimension tables. Now I'm interested in loading some data. And Snowflake and all cloud data warehouses for that matter, load data from, the data has to get to the cloud. So it needs to get to some sort of object storage in the cloud, and then we load from there. So in this example, I have a bucket out here in Amazon. It has some folders. Inside of those folders, it has some data. This data is CSV, it's gzip CSV files. And I want to load that data in. And how we do that in Snowflake is pretty simple, is that we have a pointer to that object. We call it a stage. It's the @ sign here. You can kind of indicates that this is a stage object. And I can just do a list command and I can say, show me all the files that are in that folder. So there's 725 CSV gzip files. And because this is structured data, right, it's CSV data, it has a structure, there's columns of data in there. I'm gonna create a target for this called trips. And next, when I load the weather data, I'll show you how you can load data, semi-structured data, and you don't need a schema on when you're loading the data. So created this table called trips. I'm gonna actually, the command we have in Snowflake to load data is just called copy. You can actually copy data into a table. You can copy data out of a table. So a lot of times people ask, well, how do I get my data out of Snowflake? It's really simple. You just flip these things around and you copy into a stage, which would be a bucket that you want to dump that data to. And you can configure it so people have certain privileges and can't do that all the time, and they can just query it. So okay, so I'm going to run a query now. So I loaded that data. 18 million records. I didn't see how long that took. So it took me about 8 seconds. So I loaded 18 million records in about 8 seconds. That was just 1 year of data. So a lot of times what people do is that because you're paying for these resources by the second and they scale linearly, so a small is 2 nodes, that large is 8 nodes, what people will do is they'll just, once they get used to Snowflake, they'll start to use the appropriate size to make sure it stays busy. And so what I'm going to do here is I'm going to just alter that warehouse. So you can see now it's a large warehouse. So I added essentially 6 nodes to that cluster because I want this copy command, which is going to do the rest of this bucket. It's going to load the rest of that table, and it won't load the 2019 data because it keeps track of which files it loads, and it won't reload data that it's already loaded. So I'm using a large warehouse now. Again, I ran that copy command. I'm loading into that trips table that I created up here, and I'm loading it from the stage, this stage table. So that's done. It took, you can kind of see here how long it took. It took about 20 seconds. Got some details here on everything that's happened. Can now if I want to, I can resize my warehouse so I don't have to pay for it running at a large because I'm not querying it anymore, and I can take a look at that trips table. So now I've got about 89 million records. So looks like I loaded about another 71 million records in 20 seconds. So it's, you know, I loaded what, about 4x the amount of records that I had before, and it took I guess it took about twice as long. But so you can see it's you get this linear scalability, and let's take a look at it. There it is. I've got this trips data. Now, you know, you can't just sort of like, there's a lot of situations when you're using BI that you need to create this semantic layer so people can easily query from tools like Tableau. So John has sort of been tasked with creating the semantic layer given the requirements from Jane. So he can calculate some metrics here. He can use some functions. So he wants to know how far did people travel between a latitude and longitude. We can use a haversign function for that. Okay, that data looks good. And now what I'm going to do is I'm going to create a target, or a kind of a target table that people can query. It's going to be called trips view, and this table is, you know, what Jane's going to analyze. So, okay, so it looks good. I'm going to just kind of pop over here. This sometimes takes a little while to Tableau. So I'm connected to that account, and I'm going to just do a quick update here. Sometimes this Tableau sometimes takes just a few seconds to fire up. Good, it's running. Oop. So I'm going to use this trips view as my source. Remember, I just created that table. It's in the City Bike database, the demo schema, and I can take a look at some dashboards now. So you can, with Tableau, you can use, you can still use extracts and everything, but you can also, because you have these dedicated compute resources. So Jane is actually using her own BI compute resources. She can run her own queries. So she can use this dashboard, and you know, there may be situations if the data isn't changing where you do want to do an extract, but there could be situations where you want to query that data live. And with Snowflake, because the compute resource is isolated, it makes it really kind of handy to do this. So again, these are all live queries kind of running on that trips table. So, all right. Okay, so I'm gonna jump back in here, kind of get into one of the more exciting things about our product, which is using semi-structured data. And I'm gonna show a couple other features as well here. So now I'm gonna load weather data. So again, I'm gonna set a little context here. I'm gonna use this role City Bike, and I have a production database now, right? They're using it, it's this demo schema, they're querying this trips table, or in particular, this trips view, but I don't want to impact production. I wanna actually create a dev environment where I can test this data out, make sure it works before I put it into production. So what I'm gonna do is I'm gonna create a new database. I'm gonna call it City Bike Dev, and I'm simply gonna clone the City Bike database. So I just run this command. And again, I mentioned this at the beginning, but this is a metadata operation. So we're not actually copying data, physical data. We're actually just copying the metadata. So if I run this statement now, I now have this new database here called City Bike Dev. You can see it's just like City Bike. It has those tables in it, that 90 million row trips table. It has my view. And again, this is a logical copy. It's not, we didn't physically copy the data, but we now logically have these separated, and we can start to work within this environment. I'm also going to create a warehouse called dev warehouse, because I don't want to impact maybe other people who are using that load warehouse. So I've got my dev warehouse over here. It automatically set the context. And now I want to load weather data. So again, this weather data is sitting in a bucket in S3 called weather. Just kind of show you here. There's weather data by year. And this is JSON data that's gzipped. And if I did a list here, I can see that there's about 590 files in that bucket. We can actually query the data. So in Snowflake, you don't have to load data copy data into Snowflake to see it in the blob storage. You can actually query it, and we actually, something I'm not going to show today, but we have the ability to have external tables as well. So you could never copy your data into Snowflake, but if you do copy it in, you get a lot of benefits around performance and caching. But again, I'm not going to go into a ton of detail on that. But so let's just take a look at this data. So it's JSON data. It's just a structure that's sitting in a JSON file. And the way we select that structure is just this notation $1. If I take a look at it, you can see here it's a, there's a number of JSON objects. Some of them are nested. Towards the end here, there's actually a weather object that has an array in it. These square brackets sort of show that. So it's a fairly simple structure, but there's some things going on here that are kind of interesting. And I want to load the data into my dev environment. So I'm going to click over here, use my dev environment, and then the first thing I'm going to do is, so I'm in dev. I want to create a table called weather, and this is something that's unique to Snowflake, is that we have a data type called variant, and a variant data type is a data type which will load that structure, that JSON structure natively right in. And so you don't need to put schema around it. You can load it directly in. And so if your schema is evolving or new objects are being added or things are being removed, that variant column you don't need to do anything special. It will just handle it as it comes in. So I'm going to just create this table. I'm also going to have a timestamp on there. This data, it's quite a bit of data, so I'm just going to bump up the size of my warehouse. Again, it happens automatically. And I'm going to kind of kick off this copy, which I think takes around a minute. So, so what it's doing right now is it's copying the data into that weather table, which again has this variant column and a timestamp column. And you can see it's doing that $1. So it's taking that whole object, sticking it into the variant column. And then the other thing it's doing is some light transformation as it's coming in. So we have extensions on our SQL to really walk the objects in the JSON structure. And so the notation here, you can see it's $1 and time. So there was an object called time. And what I'm doing here is I'm saying, I'm going to use a function, convert time zone. It's in UTC right now. I want to put it in New York time, Eastern time. And then I'm going to cast that as a timestamp. So essentially what I'm doing here is I'm providing the schema as I'm reading, as copying the data in. And now that copied in, so you can see it's took about a minute. I'm going to bump down my warehouse, and we can see how many records we loaded. So it's about 100 million records that we loaded, and we can take a look at it. And you can see here again, it's like, so that structure now is copied into this variant column. It's the structure. And then I also did that light transformation and created this timestamp on here. So now this may be helpful just to query on, because it was just in a, it was a epic time before, and now I can query it with a normal timestamp. And then now we can just query this data. So we can select VT, I can select the city, which is in a nested sort of object. So it's city.name. And then I'm going to cast it as a string and call it city. Similar with weather, it's an array. So with this query right here, it's putting schema around it as we're querying it. So now I have city and conditions, even though the data itself is still JSON, it's still in that semi-structured format, but I can, in real time, I can query it and provide the structure that I need to. So there's a lot of flexibility that this offers folks, because they can get the raw data into Snowflake, query it right away. If they need to materialize it, they can in a view or a table, just on the fly using SQL. just one other thing is that we have other more sophisticated sort of ways we can walk the JSON structure, but we can also flatten it. So if it's nested, if there's a nested array inside of, if that's the value of your JSON object, you can flatten it. So this is just counting like different conditions across different cities. So it's great. It looks like this is working. Now I'm ready to promote this back to production, right? So I'm working in dev right now. I have a table in dev. It's called weather, but I don't have that in City Bike. But that's actually where we want it. We want it up in this City Bike database. So what I do is I can create a table in prod, citybike.demo.weather, and I can clone this one that I've been working on in dev. So I run this command. Again, this is a metadata operation. So I now have weather up here, that 100 million row record table, people in prod. If they have access to the demo schema, they can see it. This demo environment, I don't need it anymore. So I'm just gonna blow it away. So blow it away. It's you can see that that's gone now. So I didn't need to provision anything or anything else. And let's just say I wanted it back. And I'm gonna kind of highlight this in a little bit, although I know we're running a little short on time, is that if I didn't want to blow that away, if I wanted to go back in time and say, hey, I didn't want to blow that away, I have this ability to undrop objects in Snowflake. And we call this time travel, and so now dev is here. It's back. I can query it 18 million records, and you can decide how long those objects stick around in this ability to time travel. It's up to 90 days. So I'm just going to drop it here, and we're good. So now we're operating in production. Jane wanted to know how weather impacted the City Bike thing. So what I can do is I can create a table, a view that called trips weather, and it will combine the data from the initial one I had, this trips view, and it'll combine it with the weather data, doing some transformations here, and we can run it. So it created that view, just test it out. And so, yep, it's there. We've got 89 million records. And now if we go back to Tableau, you can see here. So actually, let's go back to our data source. So what we're going to do is we're going to, let's just let this guy go. So I'm going to go back to my data source here, and I'm going to say, I want to use that new view that I've created, that trips, that view that has the weather data and the trips data. So you can see now I have that other view here. I'm just going to replace this guy. So now I have trips and weather in a view, but it has all the objects that I had before. So I'm going to, I know that my initial dashboards are going to work. So it's kind of running the query. It's kind of loading it here. And now if I go back, she was interested to say, hey, how is weather impacting trips? So this is over time how my trips are trending. But if I want to take some of this weather data, so if I want to take the temperature and I put it on this graph and say, how is that correlated to the number of trips? And let me just take the average temperature. So what I can see here is that, in September, the weather, which is this orange piece, it's nice. There's more people taking trips. I guess it gets cold in New York in the winter, so people stop riding the bikes. So down here, the average temperature is about 20. So again, it goes up, the next year it goes down. So what we can see is kind of a simple correlation here between our trips data, our structure data, and then a second data source, weather data, that was coming in JSON format that we combined together in a view. So yeah, so that, that's sort of the basics of kind of loading two different types of data. So we, Yeah, so I'm going to show kind of one other part here. I'm going to go through it kind of quickly though, so I know we have a little bit more kind of that Mike. Is that good, Mike? Do I have a little bit more time here?
Yeah, that's fine. You can go a couple more minutes. You're good. You're good. Carry on.
Okay. So just quickly, I'm going to introduce this concept of data sharing and data sharing. What data sharing means in Snowflake is that you can create a data set and share it with someone else, and they could be a Snowflake customer, or you can create a Snowflake account for them, a reader account, which is a read-only account. So they can log in over the web in their own account and see data that you're sharing with them. And what this does is it eliminates the need for FTPing files or doing different things. So jumping sort of right in here is that I'm going to sort of set some context here. And it's really simple as how we create a share is that I want to share this city bike data. And you can see up here right now is that I'm not sharing anything. There's nothing outbound that's being shared, but we can do it through the UI, or we can also do it through a GUI here, is that I'm going to share the database city bike. And then I'm going to add some objects into that share. So I'm going to add the database, the schema, and that view, that trips weather view that we had. So if we look up here right now in the shares, there's a city bike, but I need some people to actually consume that share. And these people are other Snowflake accounts. So if we go up here, I have a table here that has some mappings, and it basically maps a group of people to an account. And I'm just going to set some variables. So these variables, and then I'm going to take those variables and assign them to that share. So you can see up here in the share now that there's some people who have City Bike and they can see it. And I'm going to kind of jump right over kind of to the, just reset this here. So you can see right now I'm in this account. So there's this account HP, which is my New York City Housing Authority account. I'm going to kind of jump back here and sort of show you guys is that in that mapping table, this HP 00362 is this account, this NYCHA account. And what I can do is I'm on this account now. This is data from City Bike that they want to share with me. I can go to my shares and I can see, oh, I have an inbound share. I'm going to create a database from that share. I'm just going to call it City Bike to keep it simple. And then you can decide who sees this share. I'm going to create the database. Okay. And now if I just go to a worksheet, I now have data, this trips weather data, and I can actually query that data. So this data is in a completely new account, but I can get access to it. And if I were a Snowflake customer, I can combine it with other data that I have. But the data itself did not move out of the City Bike account. It's just a logical share. It just happens to be going to another account. And this eliminates a lot of the need for sending files and losing custody of data and trying to set up FTP or EDI kind of transactions. It's really kind of something that we think is going to be an emerging way for people to not only eliminate friction in sharing data, but perhaps monetizing their data that they have and sharing it with other people. So with that, Mike, I'm going to hand it over back to you with kind of jump back to the slides here, I guess.
Yeah, if you want to jump back to the deck, so everybody stick around because we do have and get your questions into the question log. We'll get to those in like 2 minutes here. So you can, there you go. So just a quick couple things. I mean, first of all, I just love how you sort of blithely move around and pipe in 100 million records. That's something that you used to walk away from the machine for a couple of days with. And it's just it seems like a very powerful and a great platform here. So we're excited. I did want to offer to our customers here, to our folks watching the webinar here, that we do offer a data and analytics roadmap where we can help design an architecture to accommodate changes in your technology and your data. Obviously, your BI applications are predicated upon good performant data, so we can help you review your existing system as is state, outline a plan for the future, and offer holistic, tech agnostic, and highly pragmatic guidance, whether that's migrating from, for example, maybe you're looking at that old on-premise database that's on an unsupported operating system now, that's sort of sitting there chewing up power and space and doesn't perform for your users, Well, we can help you create a plan to move that, whether it's an old cube or a data mart or your enterprise data warehouse or data lake, help you with the ETL and ELT, and or the BI tools sitting on top of that with our world-class experts. Just a quick couple of slides on Senturus before we get into the Q&A. If you want to move to the next slide, please, Chris. We are the authority in business intelligence. All we do all day, every day when we get out of bed is help people make their BI better. We're unrivaled in our expertise across that stack, and we have a depth of knowledge across that entire stack. Our clients know us for providing clarity from the chaos of complex business requirements, myriad growing disparate data sources, and constantly moving targets, and we've made a name for ourselves based on our strength at bridging the gap between IT and business users. We do that by delivering solutions that give organizations access to reliable, analysis-ready data across the organization, enabling them to quickly and easily get answers at the point of impact in the form of the decisions that are made and the actions that are taken. On the next slide, our consultants are leading experts in the field of analytics with years of pragmatic real-world expertise and experience advancing the state of the art. In fact, we're so confident in our team and methodology that we back our projects with a unique 100% money-back guarantee. We've been at this for a while. We have a long, strong history of success. We've been doing this for nearly 2 decades across 1,300 plus clients with over 2,500 successful projects ranging from the Fortune 500 to the mid-market and across functional areas, including the Office of Finance, Sales and Marketing, Manufacturing, Operations, HR, and IT. Our team is large enough to meet all of your business analytics needs, yet small enough to provide personalized attention. As mentioned before, when we were talking about the deck and the presentation, we encourage you to visit senturus.com/senturus-resources to expand your knowledge, where you can find everything from webinars such as this one to our fabulous up-to-the-minute, easily consumable blogs. Additionally, I'd be remiss if I left out our complete array of BI training across our core platforms of Cognos, Power BI, and Tableau. That includes everything from tailored group sessions to mentoring to instructor-led online courses and self-paced e-learning. And then finally, some additional resources here. If you head over to senturus.com, you can find unbiased product reviews, tech tips, insider viewpoints, again on our blog, more on this subject, interactive product demos of things like our Senturus Analytics Connector, which allows you to connect Cognos to, Tableau and or Power BI to your Cognos metadata, and then additional upcoming events, of which there are many. And with that, we will jump over to the Q&A.
Yeah, so are there use cases for an operational database? It's an analytical database, columnar analytical database. That's what gives us the performance that we need for those interactive queries. So no, it's not designed for OLTP type workloads at this time. I mean, we can handle high volumes of reads, point reads, also kind of dashboard type things, but tactical queries sometimes they're called, but we're not an OLTP database yet. MDX, we do not handle MDX queries. It's a SQL database, but you can use ODBC through Excel to connect to Snowflake. Data models, so I was just going to write this. Can we create a data model view on top of SAP HANA? We have people who replicate sort of that data model in Snowflake using views. That's how people do it. I know HANA has a GUI to do that, and we just create views. We have a number of folks, ex-SAP folks at Snowflake, and they've shown how we do that at a few customers. Wondering how those commands like cloning, copying, et cetera, have drag and drop alternates. There are, it's all done through SQL, but there are some parts of the GUI where you can actually clone and drop. Like the browser that I showed at the beginning, the databases tab allows you to do cloning and dropping and everything through a GUI, assigning privileges, things like that. So we do have that. Although it is fully functional kind of through SQL and that's generally how most people use it in production. Although the GUI does, provide you, once you're getting used to it, how to use it. Is it compatible with Cognos? Yes, we have a number of folks using Cognos and Snowflake. I didn't have that. I know I didn't have that in the picture, but we do partner with Cognos and have folks using Cognos. Yep, Cognos can use it. If you go to our website, you can see all of the folks that have written connectors to Snowflake and that we're supported with. Irwin, yes, I believe you can use Irwin. I think there's a blog post on that. I don't know it right offhand. Snowflake, you connect to Snowflake through a number of different ways. I didn't really get into this, but you can use ODBC or JDBC, the sort of generic ways to do that. For example, Tableau connects through ODBC. If you wanted to use a tool like dbeaver to write your queries, that's JDBC. We also have a Python connector, Spark connector, Go connector, Node.js connector. So if you're using those languages, you can do it. But I think Irwin probably uses ODBC. I'm not sure, maybe JDBC. So I believe there's a blog post on it. Give an example of pricing for queries. Say I had 1 million rows. Say I had 1 million rows and gets queried 10 times a day, trying to get a quick understanding of cost. So yeah, as you know, we were querying tables that were 100 million rows there, and we were using small warehouses. So Snowflake's designed for large scale queries. It's the behind the scenes, the data is columnarized, which gives us a lot of advantages as far as reducing I/O and improving throughput. Also, the way your table is structured, we eliminate partitions, so we read less data when you run a query. So this would be very inexpensive. I don't know what the price would be, but it would be dollars is what my estimate would be, because you'd only need an extra small warehouse and it should run in just a few seconds. So that's what I would say. If you want to try this out yourself, you can get a free trial at snowflake.com. You'll get $400, and there's some sample data sets there, TPCDS, and those are very large data sets, many billions of records. So you can run some of the sample queries or selects from there, and you can get a good idea without having to spend any money. SQL Server to Snowflake. Yes, Snowflake is a ANSI SQL database, and so is SQL Server. So there are maybe a few functions in SQL Server that are a little bit different, but it's relatively straightforward to migrate from any ANSI SQL database to Snowflake. The SQL queries will pretty much translate 95% of the time, and the 5% that don't are usually more just kind of find and replace kind of things. I don't know if there's a blog post out there anywhere on that one. I haven't seen one anyway. About half of our customers did previously come from another database like Redshift, so it is the conversion. There's some things out there. How long does it take someone to learn and implement Snowflake? Not long. If you know SQL, if you know databases, it's really, the learning curve is quite short, because it follows the same patterns. There are some more interesting things when we talk about external tables and automatically ingesting data and capturing change data capture streams and tests, things like that. But the core database is really easy to learn, in my opinion. So, okay, I think it's 12 o'clock, and I think we got through all the questions. Like, I don't know if there's anything else.
There was one other one here that someone had asked about, commands like cloning and copying, if there's any kind of drag and drop alternatives, or if they have to be done with as a variant SQL, Snowflake variant SQL, I guess is what he's saying.
Yeah, yeah. So in the UI, if you go, you can actually, if you wanted to clone like the weather table, you can clone it here, and
Okay, so you've got some things that are handleable via the
Yeah,
via the GUI and stuff like that.
right. Essentially, it just issues some SQL statements behind the scenes. So there are, you know, some ways to do that in the GUI. Obviously, I think there's room for improvement there, but it's essentially it's all SQL behind the scenes. But yeah, there are a few ways to load data, clone, drop, drop objects, assign privileges to them right here from the GUI. So.
Sure, and I think like like most DBAs, I know they have. It's exactly like you were showing. They've got scripts laying around all over the place that do all these things. They do a lot of copy paste.
Right. But yeah, and so like I said, you can get a free trial at Snowflake, trial.snowflake.com, and you don't need a credit card. You can actually just it takes only maybe 10 minutes to get an email back from Snowflake, and you can start going playing around with it.
Sounds good. Well, if you could toggle back to the slide real quick, just that last slide there. Thank you everyone for joining us today, and thank you especially to our presenter, Chris Richardson from Snowflake. Please reach out to us if you have any questions about this, or if you'd like to discuss doing a migration or exploring Snowflake or any of your other analytics needs. And we look forward to seeing you on one of our future Senturus Knowledge Series webinars. So thanks everyone for your time, and have a great rest of your day.